How to do a research project. Module 2.2, choose which study design to use. The second module of this course consists of executing the research study and has 5 submodules. 1. Translate idea into a specific study objective. 2. Choose which study design to use. 3. Select exposure and outcome variables. 4. Select potential confounders. And 5. Decide how data collection will be undertaken. We are currently on submodule 2.2, choose which study design to use. The learning objective for this module is to choose an appropriate study design based upon the research study objective. We will now discuss descriptions and summaries of the 2 most common experimental study designs, their limitations, and benefits. In an experimental study, the exposure to drugs, treatment, or another factor of concern is determined solely by the investigator, and the reason for assigning a specific exposure to a particular subject is to test a hypothesis and not to cater to the needs of the subject. Because the goals of an experimental study, rather than the needs of the subject, drive exposure assignment, there is an ethical limitation to the types of issues that can be studied with an experimental design. One example of such ethical limitation could be studying sleep deprivation among subjects where enforced deprivation outside of tightly controlled scenarios or strict time limits could lead to subjects' involuntary self-harm due to temporary narcolepsy. In this case, the experimental study design would be limited by ethical considerations. In a clinical trial, subjects are patients and the goal of the study is to evaluate a potential cure for a disease or to find a factor that prevents certain sequelae of a disease, such as death or disability. Treatment assignments should be assigned to minimize variation of extraneous factors that might affect comparison of each subject to the overall population. The investigator should make every attempt to deter manipulation of assignments by study personnel by making assignments random, since causal inference can be made with minimal assumptions if assignments are not random. The validity of each trial depends on how comparable the treatment arms are on all factors other than treatment itself. Ideally, the investigator should employ blinding with respect to treatment assignment or should blind whomever will be assessing the trial's outcome. We will now discuss the descriptions and summaries of the 3 most common non-experimental study designs, their limitations, and benefits. In a cohort study, the investigator defines 2 or more groups of people free of the disease of interest and differing according to their exposure to a potential cause of the disease. 1 or more groups are typically called the exposed cohort, and 1 group is typically called the reference cohort. In this figure, assume the following. A closed cohort where anyone alive without disease is at risk of developing the disease and no new subjects enter the cohort after the study begins. Relative risk equals A, exposed, divided by A, unexposed. A equals the number of incident cases over a specified time interval. A, exposed, equals the number of incident cases in the exposed, and A, unexposed, equals the number of incident cases in the unexposed. The case control study is a more efficient version of a cohort study. In a case control study, subjects, called cases, are identified by whether they have the disease or condition in question. Controls are subjects who do not have the disease and are selected from the population from which the cases originally arose. Controls should be sampled independently of their exposure status. This criterion, if met, allows the odds ratio to approximate the incidence rate ratio and, by extension, relative risk. The exposure status of cases and controls may then be determined. In this figure, assume the following. A, exposed, equals the number of cases who had exposure. A, unexposed, equals the number of cases who did not have exposure. B, exposed, equals the number of controls who had exposure. And B, unexposed, equals the number of controls who did not have exposure. A cross-sectional study may be purely descriptive. In a cross-sectional study, exposure and outcome are determined simultaneously, and their contrast is to case control. Cohort studies and randomized controlled trials are study designs where the aim is always to find the etiology of a disease or condition. The limitation of this particular study is that it will overrepresent cases with long duration and underrepresent those with a short duration of illness. The following figure illustrates the options available when choosing a study design. To review, so far we have discussed Module 1, the process of coming up with an idea. Module 2.1, narrowing that broad idea into a specific study objective. Module 2.2, the basic types of study designs most commonly employed in research studies. Now we will discuss the beginning steps to choosing a study design. The key at this point is to choose a study design that matches the study objective the researcher has developed, but this is easier said than done. Some research questions can be answered with more than one study design, as the following example will illustrate. In this example, we will use a study objective that seeks to determine whether periconceptional vitamin supplementation can reduce the incidence of a first occurrence of neural tube defects. If this was the study objective, then the researcher would have to choose a study design that determines incidence. Here, the researcher would choose a study design that starts with people who do not have the disease and then follows them over time until they develop the disease. Only 2 study designs calculate incidence, so the researcher would choose between the randomized clinical trial and the cohort study. It is important to note that incidence is defined as the number of new cases of a disease occurring over a specified time interval. Next, for the same study objective as in the previous example, if the researcher wanted to know with absolute certainty whether a treatment can reduce the incidence of a disease, or to know with certainty whether something causes something, the researcher would choose a controlled experiment, or RCT. Next, for the same study objective as in the previous example, if the researcher wanted to determine causation, the researcher would choose an experimental study design. Finally, we will imagine that the study objective was to determine whether periconceptional vitamin supplementation is associated with, rather than can reduce, the incidence of a first occurrence of neural tube defects. If, in this case, the researcher only wanted to determine association, the researcher would choose a non-experimental study design. Overall, for this study objective, the researcher could use an observational study design, such as a cohort study, but, as can be seen from the previous examples, the study design is dependent upon the study objectives. The learning objective for this module is to select appropriate exposure and outcome variables based upon the research study objective.